This is Higher Maths, it's practice paper D and we're looking at question 4 in the calculator paper. Okay, what we have here is we've got two curves are graphed, okay, one over the other here. We've got to find out the intersection of points S and T for part A. Okay, so we've got two equations of the curves here, so what I'm going to do is to try and find out the points of intersection, I'm going to let this curve equal that curve there. So for part A, what I'm going to do is I'm going to let y equal y. And what I mean by that is I'm going to let that curve there equal that one there. So let's start with this one. So 3 minus x squared, and that's going to be equal to 5 minus 2x squared. What I'll do is I'll gather everything on the left hand side and make it equal to 0, and that makes it easier to solve. So bringing the x squared over, so that'll give me x squared minus x, and that's going to be minus 2 equals 0. From there I've got a trinomial, and what I'll do is I'll just factorise that, and I'll go forward and solve it. So I've got x here, that will be a 2 and a 1, and the 2 must have the minus with it there. So x plus 1 equals 0, so x is equal to minus 1. X minus 2 equals 0, so x equals 2. And I know that the minus 1 will be the s coordinate, and the 2 for x along this way here will be the t coordinate here. Right, so let's find the y coordinates. Okay, so let's go when x equals minus 1, I'm going to substitute the minus 1 into, let's go for it, we can use either that curve or that curve. I'm going to use this one here, looks a wee bit neater for me. So that's going to be into y is equal to 5 minus 2x squared. So let's go and work that out then. So when x is minus 1, let's find out what y is. So it's 5 minus 2 times minus 1 squared. That will give me 5 minus, that will be 1, and that will be 1 times 2 is minus 2, so that will give me a value of 3 there. So that's going to be, s is going to be equal to minus 1, 3. Minus 1 from the x coordinate, and the 3 from the y. Let's do the same with the other point that we worked out. So when x equals 2, we'll just substitute it into the same equation. Now you could use the other equation here, it doesn't matter which one you use, you'll still get the same values coming out. So work out y when x equals 2, that'll be 5 minus 2, and that'll be a 2 squared there. 5 minus 8, and that should give me minus 3 here. So the t coordinate there will be, remember, the 2 from the x and minus 3 from the y. So there's my coordinates worked out already. Right, so that's part A complete. Let's go ahead and do part B. And for part B, what we have to do is we have to find the shaded area enclosed between the two curves. So that'll be this area here in blue. And the way I'm going to do that, I'm going to integrate, and I'm going to use the two curves, and I'm going to use the upper curve, which will be this one, and I'm subtracting the lower curve that gives me this part of the area here. In the integration for my limits, I'm going to set the x coordinates of t and s, and that should be me set up. So let's set this one first of all. So the area is going to be equal to, and we're going to integrate between, and remember it's the 2 and the minus 1, okay, from the x coordinates of each of these points. And it's going to be the upper minus the lower curve. And that's all with respect to x. Okay, so let's go ahead and substitute our values in, and we'll prepare this a bit, and then we'll integrate. So the upper curve is the one that when I look at the area, when I come down on top of it, there's the first curve I hit, and the curve there is 5 minus 2x squared. So 5 minus 2x squared. Subtract there the lower curve, which was the other curve, which is this one here. And what I'm going to do is I'm just going to gather that all up to make it a bit simpler and make the integration just a little bit easier. So that's going to be 2, it's going to be plus x and minus x squared. So that's just that all gathered up together, and from there we can go ahead and integrate. So integrating, that will give me 2x, that will be plus x squared all upon 2 minus x cubed all upon 3. The limits I've got still of integration would be the 2 and the minus 1. Now what I'm going to do is I'm just going to substitute these values into this expression here. So first I'll substitute the 2 in, and then I'll subtract the -1 being substituted in, and that should work out the area for me there. Right, so first thing, 2 times 2 plus I've got 2 squared all over 2 minus 2 cubed all over 3. Subtracting from that, this the -1 now just going into the exact same expression. So that'll be 2 minus 1 plus, and it's going to be -1 squared all upon 2 minus, and that's going to be -1 cubed all upon 3. So that's me got my expression together there, and if I could put that into the calculator I could just fire that in and work out my answer from there. Or what we could do is we could try to work it through. So first part that I've got here, that's going to be 4. That's going to be 4 over 2, which is 2, so that'll give me 6 coming from there. That'll be -8 over 3. From there I'll substitute, and that's going to be, well, that's going to be a -2, that's going to be plus a half, and that's going to be, that'll be -1 over 3, and I've got that minus there, that'll give me a +1/3 that comes out of there. Okay. What I can then do is just gather some bits and pieces up, or I'll just multiply that bracket out so I don't make a mistake with the signs that are going to be there. So I've got +2 minus a half, and that will be -1/3. That's a bit easier to fire into the calculator, or just gather it up even further. So that's going to be 8 minus a half, and that's going to be -9 over 3, which will just give me 3. So from there, that should work out to be, and I can work that one out, so it's going to be 8, it's going to be 5, 5 minus a half will give me 4.5, and that will be square units. That'll be the question complete. Okay, let's see the marking for this question here, and what we'll go for first of all, let's go for 1 mark for making the curves equal to each other to try and solve this. I'll take 1 mark for the factorisation of that, and 1 mark for getting the both x values for s and t there. Take 1 mark here for getting the coordinates of s and t. I'm going to take 1 mark for setting up this line here, working out the area, the upper minus the lower. Okay, and that would also include having the limits of integration in there as well. Okay. I'll take 1 mark for getting, I'll just go for 1 mark for getting this all together, just that part there, and let's see, 1 mark for integrating correctly, 1 mark for substituting in correctly as well, and finally 1 mark for the answer. Right, so that would be out of 1, 2, 3, 4, 5, 6, 7, 8 and 9, so that's going to be out of a total of 9 marks.